All right, guys. So one of the questions in our notes for today was we wanted to figure out the mechanical energy of the following situation. We have an angry bird. It drops a 0.25 kilogram egg as it flies above the ground. 5 meters before the egg hits the ground, it's traveling at a speed of 2 meters per second. And we want to calculate what's the total mechanical energy of the egg-Earth system. So with all of these problems, I do strongly recommend drawing out a diagram, just again, so you can kind of see what we're working with. So I've made one here that represents everything that we know about the following situation. We have an egg. We know that it's falling. We know that it has a mass of 0.25 kilograms. We know when it's 5 meters above the ground, it is traveling 2 meters per second. Now, it didn't really say which direction it was going. It didn't say it was going straight down or to the left or to the right. But remember, when we're talking about energy, the direction doesn't really matter. Everything's scalar. So I've just written in all the values as we see them, and this is what we can kind of start working with. So a quick thing to remember when we're looking for mechanical energy. Okay? Mechanical energy is the sum of all the kinetic and all the potential in the system. So what we have to do is, based on this information, we have to find what is the kinetic energy of the egg and what is the potential energy of the egg. Once we add those together, we can figure out the total mechanical. Okay, so the kinetic energy equation, right, and the potential energy equation. Notice that they have a little bit of overlap in that they both require the mass of the object, but where they differ is, of course, kinetic energy depends on the speed that it's going, and potential energy depends on the mass's interaction with the gravitational field and how high it is above a known surface. Okay, so I'm just going to take the values that I have and plug them into my equations so that I can start to solve for them. So with my kinetic energy, again, taking the mass of 0.25, multiplying it by our velocity squared, so 2 meters per second. Okay, when you plug that into your calculator, you should get about 0.5 joules, so not a whole lot of kinetic energy there. Okay, let's compare that to the amount of potential energy in the system. Right, so we've got our equation. Here are our values that go with that equation. Okay, so the mass times the interaction with gravity times the height. Okay, and when you plug those values into your calculator, you should get 12.5 joules. Okay, so remember that our mechanical energy, this is what we're trying to find for the whole system. The mechanical energy is equal to the sum of your kinetic and the potential at this exact moment in time. Okay, so when we add our 0.0 or 0.5 and our 12.5, the total mechanical energy should be, oops, pick that up, should be 13 joules. Okay, so that is the sum of all the energy in the system at this time. So hopefully this was helpful. As always, if you have any questions, please reach out. Thanks.